Okay, welcome back, guys. We're going to be looking at 5C today, or at least part of it anyway. So 5B, we finished. That was looking at, we're talking about things to look out for if you're looking at a statistical study, okay? Things that would give you reason not to believe the results from it, okay? So now what we're going to focus on is basically graphical ways in which we can display or organize data. Okay, we're going to look at data organization and then furthermore some graphical ways to display that data. And the reason we want to do this, guys, is because let's say you're conducting a survey and you go out and you collect a bunch of data. Okay, now we don't care about what you're measuring. But then you have all this data from your sample. So what do you do with it? Okay, well, ideally, you want to allow that data to tell a story or to create a narrative with that data. Okay, and one of the ways in which we can do that is by knowing how to organize the data and then how to display the data graphically. And that can give us some intuition as to maybe what that data is trying to tell us. So we're going to be looking at statistical tables and graphs. Okay. Now I'm going to talk about these frequency tables first, and this may be a bit lost until we actually construct one. Okay. So what a frequency table is a table that will consist of at least two columns. And it's a table in which we'll organize our data, okay? And the first column lists all the categories of the data. Now, if we're talking about numerical data, typically these categories are actually ranges in the data. So I'm going to give you an example. I'll give you an example here in a second. Look at number 2. It says the second column is going to list the frequency of each category. In other words, the number of data values that pertain to that particular category. So a very simple frequency table would be, let's say you had gone out and you had asked a bunch of people, what's your favorite color? Or what's your favorite flavor of ice cream? And you got all those responses. And so in your frequency table, your first column would just list the different colors. And then the second column would list the number of people that said that that particular color was their favorite. So for the color red, that would be like your category. If 10 people said that red was their favorite color, then that would be the frequency. Okay? Now let me give you a numerical example. Let's say you go out and you sample a bunch of your students or a bunch of your fellow students. And let's say this is in a class. You ask everybody that's in the class, what did you make on the last test? Let's say it was, well, we don't care how many points it was worth, but it was graded and the grade was given as a percentage. And so you could organize that data by creating categories. So you might have a category that goes from, let's start at the very bottom. So the lowest would be a 0, right? So you might have a category that goes from 0 to 9%. And then another category that goes from 10% to 19%. And notice I'm stopping short of that next tenth, or that next 10. And then the next category would go from 20 to 29%, all the way up, okay? Of course, if I did it that way, if I was doing it that way, then I would actually leave out the value 100. But anyway, the point that I'm trying to make here is that however many people fell into each of those categories, that would be the frequency. So if, I don't know, there were, let's think about the category from, say, 70 to 79. So the C's, in other words. Let's say there were 5 people that scored within that range. So 5 would be the frequency, okay? And that's kind of what we're talking about. This is going to make more sense here in a little bit. All right, the next slide, the relative frequency. So the relative frequency of any category is going to be a fraction or percentage of the data values that actually fall in that category, okay, divided by the total frequency. So in other words, let's say that there's a total of 25 people in the class, and 5 of those people made C's. So the total, or the relative frequency, would be 5 divided by 25, which is 0.2 or 0.20, but as a percentage it would be 20%. So we could say the relative frequency of C's in the class was 20%. That just means that 20% of the students made C's. And then finally, the cumulative frequency of any category is going to be the number of data values that are in that particular category and all the categories before it. Okay. All right. So I'm actually going to create one of these for you. You're going to have some homework exercises in which you'll be filling out a frequency table. And these are great ways to organize your data. Okay. In fact, you'll have to do this on your statistics project. Okay, so let's talk about data types. This is what I started to mention earlier, but there's 2 types of data. Qualitative. So when I see qualitative, I think of quality. Qualitative data consists of values that can be placed into non-numerical categories. So that example that I gave you about a person's favorite color or favorite flavor of ice cream, okay? Or, you know, if you go to the doctor and they give you one of those, they try to get a little assessment as to your mental state, and they'll say on a scale from 0 to 10, you know, how depressed are you, or how, you know, these different characteristics. So that scale actually represents qualities. So qualitative data is typically data that's not numerical, although sometimes it can be, and we'll look at an example here in a minute. Quantitative data, on the other hand, and think of the word quantity. Quantitative data represents counts or measurements. Okay, so these definitely are going to be numbers. It's definitely going to be numerical data. These could be things like the scores on a test, or a person's height, or a person's weight, or the age at which a woman had her first child. Okay, just things of that nature. Oh, another example of qualitative data would be like a person's favorite musical genre. Okay. All right, now when dealing with quantitative data categories, it is often useful to group or bin the data into categories that cover a range of possible values. So this is what I was talking about earlier. If the data that I'm collecting are percentages on the last test, then I can bin my data. Okay, that just means that I can create these categories or these groups. Okay, these ranges, so like from 70 to 79, and then from 80 to 89, etc. So those are called bins, and those are very important, guys. Being able to create bins that are appropriate for the data set, that's very important, okay? Because within each bin, you record the number of data values or the frequency that fall into that particular range. All right, so let's do this example in which we're going to identify the different types of data. There's only 2. It says classify each of the following types of data as either qualitative or quantitative. So part A, brand names of shoes in a customer survey. So here this survey might be asking a person, you know, what's your favorite brand of shoe? And so the data that they collect will be these different brands of shoe. And so because of that, this is qualitative data. Okay. the categories in this case, if we were going to do a frequency table, would just simply be the different brands of shoes. Look at part B, heights of students. So these are measurements, okay? So this is quantitative data. All right, and then this last one's a bit tricky, but we need to see it. It's the same type of question. Part C, audience ratings of a film on a scale of 1 to 5, where 5 means excellent and 1 probably means horrible. Okay, so the data that you would be collecting would be numerical, right? Some person might say that the film was a 4, somebody else a 5, somebody else a 2, etc. So the data is numerical. However, this is not quantitative data. It is qualitative, because although the data is numerical, those numbers are only used to represent qualities. So when somebody says that they rate the movie a 5, that just means they're saying that it's excellent. So they're describing it with that quality, excellent, okay? Or if somebody rates a movie 4, then that 4 just means they're rating it to be good. And then a 1 might represent the quality of being horrible, okay? So whenever just scales like this, 1 to 5 or 1 to 10, whatever, these actually, the data is actually qualitative. Some people think it's not because it's numerical, but those numbers represent qualities. Okay. All right. And so now we get down to where we're actually going to create a frequency table, okay? And guys, there's only one that I do in the notes, so make sure you pay attention to this. Let's see here. Well, we'll just see how far we go. Definitely going to have to break this up into 2 videos. So summarizing raw data. So raw data, that just refers to the actual data itself before you've done anything with it. So in this situation, we'll consider the following 20 scores from a 100-point exam. Okay. So all these numbers right here, guys. My computer froze for a second. Fix this. All of these numbers that you see, this is the raw data, okay? Now you can notice it's not really organized, is it? It's not even put into ascending or descending order. So there's absolutely no organization here. So if I were looking at this data and I were trying to find some trends in how the students performed on this last exam, it would be very difficult for me to do that, okay? However, if I can create a frequency table like we have down here, and I can look at that frequency table and I could say, oh, okay, well, 6 students made A's, 11 students made B's, etc. Okay, and that would give me an idea of how the grade distribution looks. All right, so what we're going to do is we're going to determine appropriate bins. What this means is by looking at this data, you're going to look at your lowest value and your highest value. Okay, so I'm looking at this and it appears as though 72 is my lowest value. And then let's see what the highest is. Here's a 98. Okay, 72 to 98. Now you could say, okay, well, we just need to create bins that ultimately go from 72 all the way to 98. Well, no, we don't typically do it that way. We typically start, maybe instead of 72, we start at a nice even number like 70. And then we go all the way up to 100. Okay? We want to make sure that our lowest number and our highest number encompass all of the data. Okay? So I think I'm going to try to go from 70 to 100. Okay? Now I need to figure out how wide do I want my bins to be. Do I want Do I want them to go in increments of 10? Or do I want them to go in increments of 5? Okay. Typically, when you're making one of these frequency tables, you don't really want fewer than 4 bins. Okay. So you really need 4 or more. Because the more, and you don't need too many bins either. You don't need the bins or the width of the bins to be real small or to be real narrow. So I think a bin width here of 5 would really be nice. And so what I'm going to do, if we're going from basically 70 to 100, that's a difference of about 30. And so if I want my bins to have a width of 5, that means I'm going to need 6 bins. Okay. And I think I'm actually going to start out, well, I guess I can start out from the top. I can say, let's let this first one go from, actually, I think I'm going to start at the bottom down here. So I'm going to come down 6. So 1, 2, 3, 4, 5, 6. This is where I'm going to start. So I'm going to actually go from 71 up to 75. Okay, you'll see why I'm doing this here in a minute. So I'm actually not going to include the value of 70. Now, wherever this one stops, that next number needs to be the beginning of my next one. So my next one needs to start at 76, and it needs to go up to 80. Okay, so this one's stopping at 80, which means I need my next one to start at 81, and it's going to go up to 85. Now, I want you to notice what's the difference here between each consecutive upper bound. The upper bound of this lower bin is 75. The upper bound of the next bin is 80. The upper bound of the next one is 85. So these are going in 5s, aren't they? So that's how you can figure out what these next numbers have to be. And now look over here on the left hand. This goes from 71 to 76. That's a difference of 5. And then 76 to 81, which is a difference of 5. Okay, and then you just keep going, guys. Since here I'm stopping at 85, my next one over here needs to be 86, which will be 5 more than the 81. And so this one will go up to 90. And then my next one will start at 91 and go up to 95. And then finally, my last one will start at 96 and go up to all the way 100. The reason I did it this way is because I wanted to include 100. If down here I started at 70, then I'd go from 70 to 74, and at the very end, I would end up going from like 95 to 99, and I wouldn't actually include the 100. Okay, so some of it is kind of preference as well. You just want to make sure that each of these bins, they all have the same width. So you can't have one bin that spans a distance of 10 and another one that only spans 5. They have to be equal in width. And then other than that, you just have to make sure that you have at least maybe 4 and that they will encompass or encapsulate all this data. Okay. So these are my score ranges, or in other words, these are what we call in this class bins. In my actual statistics class, we call them we refer to them as something different, but all right, now to find the frequencies, we're going to look at each of these bins and we're going to look back at our raw data and we're going to see how many of these raw data fall within this first bin. Okay, so from 96 to 100, and by the way, you're going to include values of 96 and 100 within this bin. Okay, so I'm looking here, and another good way to do this, if you have it printed off, which I don't know if you will, well, you probably will for your project, is as you're accumulating frequencies, go ahead and mark these out. So 98 would definitely fall within that bin, so that's 1. And I'm going to look at these other numbers. 94 will not. Neither will 91. Okay, so it looks to me like there's only a frequency of 1. There's only one of these scores that falls within this first bin. All right, what about the next one, 91 to 95? Okay, so looking on here, 94 will, so that's 1. You could even get a different color if you wanted. 94 will, let's see, 91 will, and I think that's it, so that's only 2. And then 86 to 90, okay, so you got to be careful because it's easy to miss one. Here's 88, that would work, that's 1. Here's 86, that's 2. Here's 88, that's 3. So I think 3 values fall into that range. And then from 81 to 85, so 84 will, here's 81, that's 2, and I think that's it, so just 2. And then 76 to 80, well here's 76, here's 80, 78, 76, let's see, 77, that's 5 so far. 79. So I think that's a total of 6. And then lastly, we have 71 to 74. So, or excuse me, 71 to 75. So here's 75, that's 1. 72, 3, 4, 5, 6, 7. Okay. Now you can check this, guys, because after you've taken into account all these frequencies for all these different bins, you have the total here of frequencies should equal the total number of data. So if I were to add all these up, that'd be 6, that'd be 8, that'd be 14, ooh, that's 21. Let's see. Ooh, so I overcounted 1, okay? So you got to be careful on this. It's easy to do. Let me pause for a moment and see if I can figure out which one. Okay. I think maybe I counted 1 too many in this range right here between 71 through 76. So anyway, if I were to add all these up now, this gives me exactly 20. Okay. So you just have to be careful, guys. Keep track of what you're doing. All right, now how do we find these relative frequencies? Okay, these first 2 columns that we have right here, this is our frequency distribution, or our frequency table. This tells me that that 1 person made a high A, 2 people made a low to mid A, 3 people made a high B, 2 people made a low to mid B. Or well, that I guess that's technically not true because we also have 80 down here. But anyway, the point I'm trying to make here is that this shows you more readily how the data is distributed. So you can see here I've got 6 and 6. This goes from 71 to 80. So basically around 12 people made C's, okay, which is like 60% of the class. All right, now how do I go about finding my relative frequency? Well, you take the frequency from each bin and you divide it by the total frequency, which is always going to be the total number of data, which is 20. So you'll say 1 divided by 20, and you're going to get decimals for these, so pay attention to the homework. Pay attention to whether it wants a decimal or a percentage. Remember, if it wants a percentage, you're going to have to multiply by 100 to move that decimal point to the right 2 places. So 1/20th is the same as 0.05, which is the same as 5%. Okay. And you just do all the rest of these the same. This one would be 2 out of 20. 2 out of 20 is the same as 0.10, which would be equal to 10%. Okay. And then 3 out of 20, I'm just going to skip the decimal and go straight to 15%. It would be 0.15. Okay. 2 out of 20 again, that is 10%. 6 out of 20 is 30%. 0.3, which is 30%. And then we've got another 6 out of 20, don't we? Okay. So now you can kind of see what percentage of the class fell into each of these bins. Now, finally, to calculate the cumulative frequency, you start at the top and you say, okay, one person fell into that category. And then as you go in this next row, you're not only counting the 2, but you're counting the 1 before it. So that is a total of 3. Okay, 2 plus 1 is 3. Okay, so now you've got 3 total. But now in this next row, you've got 3 more. Okay, so 3 plus the 2 plus the 1 is 6. Okay, so that's why they call this cumulative frequency, because as you go, you're accumulating frequency. And then just keep on going. 2 more. If you had 6 right here and you add 2 more, you're going to get 8. And then 6 more is going to give you 14. And then 6 more will take you to 20, such that when you're at the very bottom here, you've accounted for all 20 of those scores. Okay, so that's basically how your cumulative frequency column will go. Okay. All right, so you may need to review this, guys, at some point, because you will have to make one of these for your project. And you'll also have some homework questions in which you have to fill out one of these frequency tables. All right, well, I think I'm going to start there, sort of stop there for now. And then in the next video, we're going to start talking about more graphical ways that we can represent this data. Okay, I'm going to stop right here.